Hey everyone, today we're going to be troubleshooting the fuel system and rebuilding the carburetor on this Honda EU2000i inverter generator. This is part of a multi-video series dealing with no start and hard start conditions of this generator. You can click a link in the top right, we'll take you to the video listing for this. This carburetor was cleaned before the making of this video due to the utter destruction found in this carb. If you're having a no start condition, I urge you to first check the video on the ignition testing before getting underway with the carburetor. Click the link on the top right, will take you to that video for the testing and troubleshooting and resolution of ignition related problems. I removed the airbox so I could get at the fuel line and remove it from the carburetor. There's several points of failure here that need to be addressed before we start taking apart the carb. I've simply replaced this with a hose and a funnel. For my test, it'll be gravity fed. The reason for this is the on-off switch is not just for the ignition. If you look at the other side, it's also for the fuel valve. And the fuel valve also goes to a fuel pump. All this stuff fills up with gas rod if it's left sitting, and it causes problems, and we're just going to remove this variable from our troubleshooting. With my fuel hose in place, I could put the air cover back on to make a good seal. I elect to use two small rubber hoses and tighten them down with the nuts from the air cover, and that will make a good seal against the side of the engine as well. This will also allow me to conduct some further tests. Does the engine only start or sputter or run when the choke is in the closed position? Does the engine only start or sputter or run when your thumb is covering almost the entirety of the inlet of the carb? Does the engine seem to run smooth, but you always have to have it in the choke position to start it, even when the engine is warm? If you could get the engine to idle with or without the choke, does it die as it speeds up when you shut off the echo throttle? Is there any speed change when toggling echo throttle? If none of these tests were successful, has starting fluid been sprayed directly into the engine in order to see if it kicks over, to be sure that it is in fact a carburetor and or fuel delivery issue? If any of these holds true, we'll be doing a carb rebuild. I have a kit that I've purchased, link in the comments below. And get a fuel can or a container under the drain hose here first. Open up that valve with a flathead screwdriver. Just drain the bowl before I remove the carburetor. Close that valve up when I'm done. You should do this when you're putting the generator away. You probably wouldn't be rebuilding the carburetor. I'll remove my temporary carb mounts with the hoses and my test fuel line. We can see that these gaskets have seen better days. The governor cables can need to be removed from these harnesses, so I unsnap this first one, and then there's a cable tie that could be released from the second one, and then I unclip the connector from the back here and remove it. Pull this cable out. Carb's removed, we'll bring it over to the bench. On top of the carb is governor. This will be removed first. It is held between two forks on the top of the throttle of the carburetor. We're going to loosen it with a Phillips screwdriver and remove it straight off the top. Mine is missing a small spring, I'm aware of that. This fitting holding one hose can now be lifted off. The other hose can be pulled off this pipe. The nut securing the bowl is loosened with a 10 mil. There is a replaceable washer under the nut. You'll see that just dropped. I'll put it back on the nut so I don't lose it. Opening the bowl, I said this was already pre-cleaned. We do see that the gasket is really dried out. I remove the float pin to separate the float assembly from the carburetor. Then using a fitted screwdriver, I carefully loosen the main jet from the bottom, unscrewing it and hitting it to knock it out. We see the emulsion tube is still in there. From the top, I push down gently on the emulsion tube to unseat it, and then hitting the carb again, I knock it out from the bottom. The idle stop screw will have to be loosened next and completely removed from the unit. This provides access to the pilot jet seen here. This is going to be pried up, and as I pry it up, I realize there's absolutely no resistance. The O-ring on here is completely toasted and probably provides for a considerable vacuum leak. I'm going to put it back in to check, and there's no resistance going in. Yeah, this thing is hosed. During that test, the generator would only run on choke or with the finger completely covering the front of the carburetor. This is probably a good reason why it was doing that. And this is what this generator was doing. The low-speed needle is not removable and is tamper resistant. There are ways to ensure that the passages are clean. We'll go through that later. Time for a cool animation. Prying off this float O-ring here, and if this is an indication of the condition of the rest of the rubber in this carburetor, we could see that it's in a bad way. It's all got to go. I did want to take a moment to take a razor blade and make sure that all this material here was flush, so I removed it carefully. This is a standard procedure of spraying it through with carb cleaner and then blowing it out with compressed air. You could also use ultrasonic cleaner if necessary. This one was a candidate for ultrasonic cleaner. Like I said, this one was in a really bad way, completely impacted with varnish and rot. That included this main jet. You could not see the contours of this jet. It was completely filled with garbage. This was sprayed and blasted through, and then something non-metal was used as shown here to make sure that it was unobstructed. It's further cleaned out with the metal polish and the brush to ensure that any amount of garbage that was in this area of the jet has been completely removed. The emulsion tube was also completely impacted and required a cleaning out, blowing out inspection, just like the jet. These pieces are now ready to go. The rubber on the pilot jet was so petrified that it needed to be cut off. We could see that it just kind of cracks right off of it. Under pressure, it just split right in half. This jet needs to be hit with carb cleaner and blown out with air just like any brass jet. I use this thin metal wire only to illustrate where the hole is on this jet. I'd never recommend cleaning the jet with a metal wire. This is just for illustration only. A new pilot jet O-ring came in my kit. It should be pre-lubed. Here's the ring. I'm going to use some Rem oil, spray it on my fingers, and then get it on that O-ring. And I'm just going to seat it right over. Falls right into place. Get a close-up look at that. A little Rem oil was sprayed inside the carb too. Now when the O-ring is correct and working, and this flat lines up properly, this should seat and press in with resistance, so it actually makes a seal, and this one does. So I know that it's going to be good. Now the idle stop screw is introduced. It's screwed in just until it bumps the throttle. Back off if gone too far. It needs to be set up with the actual engine running. Drop in the emulsion tube, followed by the jet. Screw it in with a fitted screwdriver to full seat, and then just give it a little nudge tight. If the float needle is damaged, it's going to need to be replaced. This one seems serviceable. I'm going to install it. And then slide the pin through to secure everything into place. Now, even though this is not adjustable, to make sure everything is okay, I've set my calipers to 12 millimeters, and measuring from where my eye sees, it looks like the float is sitting at 12. So now I open up my seal kit and spray some Rem oil on the bowl seal and install it into the recess. There are a couple notches in the seal that help press it into place, and I push those down now. And then I put a new seal on this nut. Place the float bowl back on, keeping in mind the correct orientation. Drain points towards the air filter. Put the nut back in, hand screw it all the way down, aligning the bowl position as I work. Check for the position one last time. And then snug it down with the 10 mil. I'm going to check the drain O-ring right quick, see if it needs replacing, because I have one from the kit. As I pull it out and take a look with the pick, I see that it's still fine, so I'm going to put it right back in and save that one for a rainy day. It's just never exposed to gas, so it wasn't destroyed like the others. These hoses should be washed and blown out with air if necessary. The first one pops right back on the fitting. It's then rotated back into position to align itself for the second one, which seats back onto the bracket which it was removed from. If the governor had failed at this point or through the course of troubleshooting, it may be required to do further testing on it. Pushing these three clasps will open it up. So I'll push one and then the second one, and then I can pop the cover right off. And it exposes this cable here we're going to disconnect. Just take a flathead and twist it like that, and the cable will pop out. And we see here there are 5 pins, but the one all the way on the right is not used. I'm going to set my ohm meter on ohms, and then I'm going to take a baseline reading, find out where we are, and it looks like we're going to be subtracting 2.5 ohms from our value. Take a measurement between pins 1 and 3. I should see between 50 and 70, and I see effectively 60. We're good. Same thing on this one for pins 2 and 4. Again, I see 60, so this motor is good. I switch over to continuity, and what I'm going to do is I'm going to check end to end on these cables by color. I'm going to do this on all 4 and see that they're good. A last ditch effort would be cleaning the connectors and trying again, because at that point mainboard issues would be very expensive. This screw needs to be dropped in before the cover goes back on. and then the cover snaps back in. We're ready to reinstall it on the carb. The governor is now aligned. I realize that spring is missing, but I put the governor between the plastic piece on the throttle and then align the 2 screw holes on the mount. And then I screw it down with a Phillips screwdriver to secure the governor, being sure not to over-tighten this plastic piece. I check that the linkage to the governor is seated properly within the throttle, and then when I'm sure, I push it to the full open position. New gaskets were provided to mount the carburetor. Toss this old gasket, this is done. Put on the new gasket provided, and we're going to slide the carburetor right on and test it as we did before. Keeping in mind the carb is not designed to be run without the air filter and cover on. It'll run a bit lean, but it'll be good enough for testing. Going to use the hoses again. Tighten it down by hand. This should show us if the carburetor is at least working properly so we can move on. Sprayed the terminals on the governor with deoxit and plugged it back in. Plug in my overhead temporary test fuel connection. And I'm going to fill up the funnel with some gasoline. This is ethanol-free gasoline I use for testing. Set the choke to on. The echo button is on the generator. I'll give it a pull. Fires up with no effort. We take off the choke. We do hear a little bit of sputter on the speed changes. We'll get back to that in a minute, but it does smooth out. I'm just going to gently touch the governor to see that it bounces back in the right speed to ensure the governor is working properly. And it is. Now I'm going to flip echo from on to off to see how it handles speed changes. And you can see that it is quite abrupt and shaking. We'll do it one more time. This is because that spring is missing between the throttle and the governor, so I'm going to go and add that right now. I've cut a replacement spring and fit it. We're going to set it back to choke and retest again. I can already see that that transition was smoother. Shut off echo now. The transition to different speeds as well as running under higher RPM is a lot smoother now with the spring. You see a big difference. Comes down a lot smoother too as well. And this is without the filter or the assembly, so this is still not ideal. Also, the idle stop hasn't been set yet. That'll be done at the very end. But everything with regard to fuel delivery seems to be working real nice now. As I shut down this engine, it's important to remember that if I'm going to pull something like this out of the carburetors, it's probably in the rest of the fuel system. And it looks like this, coming right out of the gas tank, through the fuel pump and associated hoses. You don't want to run this. So we're going to start at the gas tank and open it up and have a look inside and pull out this filter over here. It's a pre-filter. And it is nasty in there. If you filled it up with gas, tried to run this, you just break the carburetor immediately. So this is going to be buttoned up on the bottom. And what I'm going to do is I'm going to fill this up with kerosene. And I'm just going to pour it in and splash it around. Shake it around a couple times a day as I walk past it for the next several days. You know, as parts arrive. This is something I started on early in the project so that it would break up all that varnish. While that's soaking, I'm going to start disassembling the rest of the fuel components, cleaning them out individually with carb cleaner, watching the varnish just melt out of these parts. There's the filter that goes into the gas tank. Spraying that. And it is coming out just slow, so they're soaking too. And look at this. This is the lowest point in the system. This is the valve. Look how bad that is. And I've cleaned everything up individually and inspected them. There's nothing more contaminating these systems. The valve was easy to check with carb cleaner. It's definitely open and there's no more contaminants in it. The pump has been cleaning contaminants, but because it works on vacuum, it's going to need to be checked on the generator itself. So we're going to stage these components on the generator to make sure everything's working. This has been sitting in kerosene and agitated for several days, so we're going to empty it now. Blown out and then rinsed. This gas can is now perfectly clean. There's nothing in this container. The pre-filter was clean, so I drop it back in the gas can. And the gas can situated right back on the rubber mounts. I'll reconnect my test fuel line because it'll still be running the engine. However, the rest of the fuel system will be reconnected independently. This is the fuel filter going into the tank. Being sure to slide that clip back up to the top where the tank meets the connection. I'll use a pair of pliers to secure the clip. This hose right here with the white stripe is the vacuum. I reconnect this to the pump. The fuel line won't be connected. I use a twisty tie here to temporarily hold both of these brackets together up top. I should use a flat pan for this. This is a lesson about what not to do. I turn the fuel on. Only need enough gas in the tank as to test the pump, so not a lot. And then just enough gas in the funnel to run the engine for a couple of seconds. Purposely left this in the video. Be sure to use a pan for this. Not that. So I did grab the jar in time and collect the gas to show that the pump does work, and then I killed the engine. Be safe out there, people. With a fully clean fuel system and a pump that does work, I'm transferring the remaining fuel from the funnel into the gas tank and removing my temporary fuel delivery system. Now I can connect the fuel line coming off the pump into the carburetor. Snap it into position. I'll add more fuel into the tank now for continued testing. The cap was also cleaned and inspected, so I'm going to put that back on now and make sure it's switched to open. For further testing and to demonstrate another common issue, I'm going to plug in my kilowatt. We'll be using my 750 1500 watt heat gun as a load. So coming off choke, the kilowatt turns on, and we're looking at about 123 volts, which is good. Flipping through the watts now. That echo set to on, and I'm going to flip the switch up to 750 watts. We can hear the generator bump and the heat gun turns on, and we're seeing about 760 on the display, so that seems fine. Flip it to 1500. And it dies. Let's get this started one more time. We're going to try it a different way. Let everything come up, and then we're going to set it up again for watts. Flip it again to 750. We're going to get the same result, and we look on the indication, and we're getting 760 just as before. This time I'm going to shut off echo throttle first and let it come to a higher RPM, and then I'm going to hit 1500 watts on the heat gun. Now this time it didn't die. It's hitting about 1200 watts, but it's hunting and it's surging, but it's definitely not working correctly. But the problem is very telling, and this tells us exactly what's wrong and how to fix it. These carbs have very little tolerance. They're designed to run with the restriction of the air filter and the air box. Running them with any leaks in front of the carburetor will cause a lean condition, which will especially get worse the more load is applied to the engine. This gasket often missing is very important as well. So I'm going to apply a new one. I've cleaned the face of that carb earlier before. And then the airbox, which should have both filters, and the airbox can't be cracked or broken or warped or whatever. These two nuts get lightly snugged down. Make sure we have a correct filter, not some piece of foam we cut out and stuffed in there. And this breather hose has to be connected or it causes a leak. Every piece of the system is correctly connected. Let's give it a run now. About 125 volts off echo. Set up on watts. Very smooth transition into 750 watts. It's actually 780. And now we're seeing 1489 without effort. The problem was completely removed by closing up the front of the carburetor, the air filter, and whatnot with all the correct parts. Now I'm going to retest this in echo mode where it had initially died, and we're going to see what happens. It does take a bit longer to climb to 760, but it did without any problem. But that's what happens in echo mode, so it worked just fine. And 1500 watts, no problem in echo mode. Everything's working perfectly now. This fuel system is fully repaired. Finally, I want to turn the throttle stop screw in echo mode till I hear the RPMs just start to climb, back off till they come back down, and then another further 3/5 of a turn. So I hope you found this video on the troubleshooting and repair and carb rebuild of this Honda EU2000 enjoyable, entertaining, and informative. Do me a favor, hit that like button down below. It helps me out a lot when you do. And hit that subscribe button for more videos like this when they come out. When the next video comes out, a link will be posted in the top right corner. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?